So this program demonstrates a binary search. And one of the things that you'll notice, and let's just take a look at what we have here. We have an array of ID numbers. The size is 20. There's 20 of them in there. This variable employee ID is going to hold whatever ID we choose to search for. We're going to let the user enter it. And results is going to hold the search results, which is just going to be the index where we find the employee ID, or it's going to be -1 if we don't find it. This is exactly what we saw with a linear search. So you'll see the call is pretty much the same, except it's calling the binary search function. When you come back from that, if it's equal to -1, it'll say it doesn't exist. Otherwise, it displays the results. So it's important to note whatever search you choose to use, you're going to bring in the array, the size, and the search value, and it's going to return out the index where it found it, or a -1 if it doesn't find it. So the only difference here is the code is different. Okay, so let's just run it, see what it does, and then we'll look at the code. So I'm going to pick ID 296, which is actually there. And it'll tell me it was found in element 9 of the array. I'm going to run it again, and I'm going to put in 555, and it'll say it does not exist in the array. So let's take a look at the code here. With the linear search, a linear search always starts at the beginning of the array, and it checks the first element, the second element, just linear. It goes through in a linear fashion through each of the elements in the array until it finds it. Binary search is different. Basically what it does is every time you search the array, it will be able to cut the list in half. Now the one thing you have to note for the binary search, if I come up here, you'll notice that these are all in ascending numeric order, right? 101, 142, 147, 189. And in order for a binary search to work, the list itself, or the array itself, has to be sorted. It's required, okay? So what happens is, if we look at this array, we have 20 elements. The size is 20. So first is going to look at the first element in the array, which is at index 0. Last is going to be the last index in the array, which is 19. And middle is going to find an index in the middle of those two. So we still have our position set to -1 and found is false. While not found, that's true. And 1 is less than or equal to, or 0 is less than or equal to 19, that's true. We find the middle element, and we do this with integer division. So first plus last is 0 plus 19 is 19, and 19 divided by 2 is 9.5, but we don't use the 0.5, so we just have 9. So the first time through, it's going to look at array sub 9, which is the middle element. And if we come up here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there, that's going to be the middle element. So, if I was looking for instance, 142, if I look here, it's not 142. I know it needs to be in this portion of the array if it's out there, because the array is sorted. So what happens here is the next time through, it's going to look through index 0 through 8, just this portion of the array. And we'll see how that gets done down here. All right, so if array sub 9 is equal to the value, no, it's not. If array sub 9 is greater than the value, and again, we'll use 142, yes it is. So last is going to be middle minus 1. So last is going to be 8. So now when we go through our loop again, not found is still true, and 0 less than or equal to last is true. So it's only looking through indexes 0 through 8. So every time through the algorithm here, or through the while loop, it really can eliminate half of the elements in the portion of the array you're looking at.